Today's lesson is called Exponential Growth and Decay. We'll start with an opening exercise. It says decide whether the following exponential equations model growth or decay. I have 4 equations there for you. And then underneath, I would like you to write, how did you decide? So this is a review of something that we discussed in a previous lesson. Please pause the video, try the opening exercise on your own, and then resume the video to go over the answers. Okay, now that you tried on your own, let's look at each one. A, f of x equals 3 times 2 to the x should be growth. B, f of x equals 1/2 to the x should be decay. C, f of x equals 3 times 1.6 to the x should be growth. And D, f of x equals 0.8 to the x should be decay. So how did you decide? I said if the b value is larger than 1, it is increasing, so growth. And just be careful when I'm talking about the b value. The b value is the one directly attached to the exponent. So in part A, that would be a 2. In part B, that would be 1/2. In part C, that would be 1.6. And in part D, that would be 0.8. And then if the b value is smaller again than 1, it is decreasing and would be decay. So that's what you should have been looking for to decide whether this was growth or decay. Okay, now let's talk about now where that came from and use a formula to answer exponential growth and decay problems. The formula for exponential growth is y equals a times 1 plus r to the x. So what do these values mean? A is going to stand for our initial amount. So what we're starting with, that value will be outside of the parentheses in front. R, in this case, it's standing for the growth rate. Obviously, the R coming from the word rate. And then the X is going to be our time, and that should be in years. At the same time, we can slightly tweak that formula and have a formula for exponential decay. So for exponential decay, there's only one small change. We'll do y equals a times 1, and then instead of adding r, because this is not a growth problem, we're going to subtract r because this is decay. And then a little x as your exponent. So the a value is still your initial amount. R this time is going to be a decay rate. And x is going to be your time in years. So the formula is basically the same. The thing I would say to you is it's plus if it's growth and it's minus if it's decay. You're adding the rate if it's growing. You're subtracting the rate if it's decreasing or decaying. So there is another way to look at it, and this is essentially what you did in the opening exercise. So for an exponential function, remember it's going to be growth if the base value is larger than 1, like we did in the opening exercise. So that would be maybe the example f of x equals 3 times 1.6 to the x. If I look at that b value, 1.6 definitely tells me that I must have added to 1 in order to get that number. So that tells me that was a growth problem. Also, the value is over 1. It'll be decay if the base value is less than 1, which we discussed before. We don't want to be below 0 either. Remember, that's going to be between 0 and 1. And your example here would be f of x equals 1/2 x. That would be one that you could tell right away because you see obviously that this value is below 1. So we must have done 1 minus the rate to get that value. So I want to move on and do an example of using the formula to answer a question. So it says in the census survey at the end of the year 2010, so I'm going to go highlight that information, end of the year 2010, the population of Pendleton, New York was 6,397 people. So this information at the top we're now going to use for part A and for part B. We'll start with part A. It says write an exponential equation, and they want us to use P of t to write it. So I know back here the general formula was y equals. Now that we know that we're changing it to P of t, we'll use P of t instead of y, and then t is the input instead of x. So where the exponent was, we'll now use a t. So write an exponential equation P of t to model the population if it's expected to grow by 8% per year. It says use your model to predict the population in 2019. So the population is expected to grow. So that's the first thing I want to write down. So the growth formula that we gave you, the general formula, is y equals a times 1 plus the rate to the x. The only thing that's going to slightly change here now is that we're going to have P of t equals a times 1 plus r to the t because of the way the problem said to express it as a function. Okay, my initial amount is still my a value. That's the 6,397 number. Our rate is 8%. But just like we've discussed before, you do not put the percent in the formula. You need to change it to a decimal. So what I'm actually putting in the formula is going to be 0.08. Remember, move the decimal place 2 places to the left, or in other words, you're dividing by 100. And then x, usually in the formula, is now going to be t. And so t, we have to figure out. So the starting point was the end of the year 2010. This is where we're talking about end of the year. That's where we're starting from. So when I look and see 2019, that means I have to figure out how long it's been from 2010 to 2019. That would be 9 years. So I'm going to put 9 there, and then in parentheses, we'll put that's from 2010 to 2019. So now we have all the information that we need to fill in our formula. So we'll have P of t, which is now P of 9, equals our a value was 6,397. Since it's growth, we're doing 1 plus the rate, so 1 plus 0.08. And then we're going to raise that to the 9th power. 9 is going in for t. So you would go to your calculator and type this in exactly as you see it, making sure you do the 1 plus 0.08 first, raise it to the 9th power, and then times it by 6,397. Again, I would write that in as a full expression on my calculator, parentheses included. And you end up finding that P of 9 is equal to 12,787 point, you're going to get decimals, 6, 3, 2, 5. I'm going to say and so on. And we're talking about the population. So we have to round to the nearest person in order to have a final answer here. So we should have that P of 9 is approximately 12,788 people after our rounding. So that would be our final answer. Now in part B, we're going to switch and we are going to do write an exponential equation. They still want us to use P of t to model the population if it is expected to decrease by 8% per year. It says use your model to predict the population in 2019. So one thing I will do up here, though, is it did say to write the equation and then find P of 9. So I'm going to slide this down and make sure that we officially wrote the equation here. Our equation should have been P of t equals our initial amount, 6397, times 1 plus r to the t. Okay, and instead of the r there, we should have had 0.08. So that is our formula, because now no matter what I put in for t, I can find the answer. And then underneath, I found P of 9. Okay, so here in B, this time we're talking about decay. So the original formula I gave you was y equals a times 1 minus r to the x. Because we're using P of t here, that would change to P of t equals a times 1 minus r to the t. So we're just changing our y and we're changing our x because it's function notation. My initial amount is still the 6,397 number. My rate is 8%, which means I'm using 0.08. And my time, t, is still 9 because we're still going from 2010 till 2019. So t is 9, again, because we went from 2010 to 2019. So my model, my formula, would be P of t equals 6,397 times 1 minus 0.08 this time because it's decay to the t. So that's my actual formula. Now I will use it to find P of 9. So P of 9 would be 6,397 times 1 minus 0.08 to the 9th power. Once again, you can type that all into your calculator. So that gives me P of 9 equals 3,020.4162 ... I'll do is so on. And remember, since this is people, we're going to round to the nearest person, the nearest whole number. So P of 9 is approximately 3,020 people. So there's a quick example of how to do exponential growth and decay. Most of the time, they'll ask you to write the formula first generically, like we did on the top line on the right, and then they'll ask you to evaluate for a certain amount. And it's good to be prepared for them giving you years and you figuring out the t value or the x value. They may not always just say this many years right out front in the problem. For the last thing, we want to look at example 2. The value v of t of a car depreciates according to the function v of t equals 24,500 times 0.85 to the t, where v of t represents the value of the car in dollars and t represents time in years. So v of t is how much the car is worth, t is the time in years. In the function v of t, explain what the 0.85 and the 24,500 represent. So this question is very similar to what you've done with linear functions. In linear functions, you've been given equations and have to describe, in that case, what the slope is and what the y-intercept meant. So this is the exponential version of that same type of question. We have the function in front of us. We know the number out in front should be our initial value, our starting point, which means that's the y-intercept. So they're asking you to explain what the y-intercept means. And then inside, because we know it's either 1 plus the rate or 1 minus the rate, they're basically asking you to explain, based off the rate, what is happening year after year, telling me if it's growing or decreasing and by how much. So very similar to describing a slope and y-intercept, just in the exponential form of it. So we want to start by using the 0.08 or the 0.85 was first. And we want to say what that means. So think about what the formula is. Inside the parentheses, it's either 1 plus the rate or 1 minus the rate. And this number is below 1. So I should know that this is a decay or depreciation problem. So what I would say is 0.85 means that the car's value is 85% of the current value each year. More specifically, underneath, I want to address the fact that that came from doing something. So I'm going to say 1 minus 0.85 means that it depreciates 15% per year. So first I'm saying that it's 85% of the current value. So whatever it is, it's only worth 85% of that. So if I look at it from a perspective of the formula, I did 1 minus 0.85 to see what my answer would be. My answer to 1 minus 0.85 is 0.15. So that means I must have done 1 minus 0.15 to get the 0.85 that was actually in the formula. So that means this car is really depreciating, which is decay, 15% per year. Now the 24,500 is in the initial amount part of this formula. So this tells me 24,500 is the original value of the car. And that completes your lesson on exponential growth and decay.